Welcome back, grade 9. This is chapter 6, section 1, which is momentum and impulse. In this section, we will talk about momentum and impulse, and we will understand everything about this lesson. So please be focused. How exactly does a seatbelt save lives? In this video, we are going to learn about the forces acting on an object due to the change in momentum. You may find it useful to brush up on momentum by watching this video. All moving objects have momentum. A stationary object has a momentum of 0. We calculate momentum using this equation. Momentum P equals mass M times velocity V. This explains the definition of momentum, which says a quantity defined as the product of the mass and velocity of an object. So the unit of momentum is mass is measured in kilogram and velocity is measured in meter per second. So momentum equals kilogram times meter per second. Now let's try this example. What is the momentum of 100 kilogram ostrich traveling at 8 meters per second? Pause this video while you work it out. What did you do? Rapid changes in momentum can be extremely dangerous. Can you think of example of rapid changes in momentum? During a car crash, the momentum of a passenger decreases rapidly from a large number of 0 in less than a second. This places a huge force on them, which can be lethal or cause a serious injury. We can calculate the force acting on the passenger using the equation. Force equals change in momentum divided by time of change, where the force is measured in newtons, momentum is measured in kilogram times meter per second, and time is measured in seconds. Let's try this example. So 100 kilogram ostrich is traveling at 8 meters per second. What force is required to stop it in 5 seconds? So first, we need to calculate the change in momentum. Momentum at start or initially equals mass times velocity, which is equals 100 times 8 equals 800 kilogram times meter per second. Momentum at the end equals 0. That's because the ostrich stopped. So the change in momentum equals 800 minus 0, which is equals 800 kilogram times meter per second. Now we need to substitute this value into our equation. So force equals change in momentum, which is delta P, divided by time, it's change in time, which is equals 800 divided by 5 equals 160 Newton. That's a lot of force. Imagine a person with a mass of 70 kilogram is traveling in a car at 15 meters per second. The car comes to complete stop in 1 second. What is the force acting on the person? Pause the video while you work it out. Now check your answer. That force acting on a person could be fatal. Rapid changes in momentum create a huge force that are dangerous. Car manufacturers use crash test dummies to study the forces the body is subjected to. In various crash situations, we can make changes in momentum less dangerous if the change happens over a longer period of time. With no seat belt, the body will move forward and comes to rest rapidly. As the person hits the stationary part of the car, a seatbelt stops the driver from being thrown from the car and allows a longer time to slow the body down by locking and stretching during the crash. Seatbelt, airbags, and crumple zone all reduce the force by increasing the time over which the change takes place. So now you can see how seatbelt can save your life. Now we need to be more specific. So I will talk about impulse. An impulse is something that an object experiences. Okay, so force acting over time. This is the something that an object experiences. It's force acting over time. An object can experience a force that acts over a course of time. Now, when an object experiences this force, as example, you are running through a room and someone grabs you by the shirt and pulls you backward, yeah. You have experienced a force acting over a course of time, and what that did is it resulted in something. It resulted in a change in your velocity. Now, likewise, you could also be moving down a hallway and someone shoves you from behind. In the same way, you are just experiencing a force from behind acting over a certain period of time. And that time period is how long the person's hand that they are shoving you with was in contact with your body. Now, what I want you to see here is this. When you experience an impulse, you are experiencing a change in momentum. Now, I use the word force up here, but specifically, I should clarify that is an unbalanced force. So specifically, when the force is unbalanced, you are experiencing this thing known as impulse, which is nothing more than a force that's acting over time. And when that force acts over a course of time, there is a result, and the result is a change in your momentum. Okay? Remember that momentum is mass times velocity. Again, momentum is mass times velocity. But in this case, I'm also doing something different. I'm saying it's mass times a change in velocity. Yes, it's delta V. Now when I use this little triangle here, that means a change because you have changed velocity. We are looking now to a change in your momentum. Yes. So I hope you get this little preview here that an impulse is related to a momentum changes. So check out the formula for impulse. An impulse is gonna equal a change in momentum, and that's what I want you to see over here. This is a change in momentum. Mass times a change in velocity is going to equal a change in momentum. So over here, a force multiplied by time, yeah, that's my impulse. So an object is going to experience a force through a course of time that changes the velocity of an object. Well, the cool thing here, guys, is that we look at a force in time. They are not new units for us. They are old units, and we are simply just rearranging them in a different way now. The unit for impulse is going to be the Newton second. That's correct, yeah. That's because force is expressed as Newton and time is expressed in a second. And it's not force divided by second because they are multiplied together. It's force multiplied by second, and that's, yeah. Sorry. So it's force multiplied by second. And that's going to equal mass, which is kilogram, times a change in velocity, which is meters per second. Now, impulse is a force that acts over a course of time and also is the change of P. Now let's talk about impulse and momentum theorem. The impulse momentum theorem states that when a net force is applied to an object over a certain time interval, the force will cause a change in the object's momentum. Remember that momentum, which is P, equals mass times velocity. So the change in momentum equals mass, which is constant, final velocity minus mass times initial velocity. So we have final velocity minus mass times initial velocity. So as a result, this is the impulse. Impulse equals force times time interval equals change in momentum, which is delta P, here, and the change in momentum equals mass final velocity minus mass initial velocity. So the impulse equals the change in momentum. So as a final result, this is the impulse, which is force multiplied by time equals change in momentum, which is mass final velocity minus mass initial velocity. And this is the theory of impulse momentum. And this is the formula we will use to solve our problems. Let's move to the book problems, page 193, question number 1. A 0.5 kilogram football, this is the mass, is thrown with a velocity of 15 meters per second to the right. So this is our initial velocity to the right. A stationary receiver catches the ball and brings it to rest in 0.020 seconds. This is the time. And this is, and brings it to rest. This is the final velocity. So the initial velocity was 15 meters per second, and then the ball stopped and comes to rest. So the final velocity of it is 0 meters per second, and the time is 0.020 seconds. What is the force exerted on the ball by the receiver? He is asking for the force. So first we will use our formula, which is the impulse momentum theorem. Force multiplied by T, which is time, equals mass final velocity minus mass initial velocity. Now I have to get rid of the T, which is time. So I will use the division here, divide by T, divided by T. So the T comes here. So mass final velocity minus mass initial velocity, all divided by the time. So force equals, mass here is 0.5, and then times final velocity, which is 0, minus mass, which is 0.5, times initial velocity, which is 15 meters per second, all divided by 0.020. The force here equals negative 3.8 times 10 power 2 Newton to the right. You don't need this step. It's enough to reach this step. The final step here is he got rid of the negative sign with the right, so it became positive sign with left. You don't need this step. I hope you understand this problem. Let's move to the second problem. To the third problem. I don't need you to solve number 2 because it have an idea of the second semester, I think, so you don't have to solve it. Let's move directly to number 3. 0.4 kilogram soccer ball, so this is mass, approaches a player horizontally with a velocity of 18 meters per second. This is the initial velocity to the north, so it's upward, it's positive sign. The player strikes the ball and causes to move in opposite direction, so the ball moves in opposite direction, which is to the south, which is negative sign, with a velocity of 22 meters per second. Remember, he didn't say negative 22 meters per second, he just said opposite direction. So opposite direction means opposite direction means it's moving to the south. To the south. So it's negative sign. It will take always negative sign. What impulse was delivered to the ball by the player? He is asking for the impulse. So pause the video and try to solve it by your own. Now let's check the answer. First, he used this formula, which is change in momentum, which is impulse. Remember that the impulse equals a change in momentum, and change in momentum here, which is delta P, equals mass final velocity minus mass initial velocity. So 0.4 times negative 22 meters per second, which is the final velocity, which I said before, it's south, means negative sign, minus 0.40 times 18 meters per second with positive sign. So the change in momentum or the impulse here equals negative 16 kilogram meter per second. I hope you understand this this problem, and try to solve by your own the rest of the book problems. Let's move to the final thing in this video. Now, once you understand that when the unbalanced force is in the direction of motion, this is an example of you walking into the hallway and someone pushes you from behind, and you are pushing you and they are pushing you in the same direction that you are going. We are gonna see change in momentum that is an increase in your momentum because your velocity is going to increase. Yeah, so unbalanced force and the direction of motion increases the momentum, as you can see here. But when that unbalanced force comes in opposite direction, such as you're walking down a hallway and someone grabs your shirt from behind and pulls you backward, the force is applied in the opposite direction that you are going. We're looking at a decrease in your momentum because you have a change of velocity and your velocity is going down. As you see here, unbalanced force in the opposite direction of motion decreases the momentum. Yeah, opposite direction decreases the momentum. Now I hope you understand this section. This is the final point. This is the end of this section. I hope you understand this section very well. Now try to solve the book problems and send me. I will send you back. See you in the next video. Bye bye.